Okay, we're about to start Chapter 2, and Chapter 2 is titled Solving Equations and Problem Solving. And the first section in Chapter 2 is Simplifying Algebraic Expressions. So let's begin by talking about what exactly algebraic expressions are. Algebraic expressions are basically math sentences that contain ordinary numbers, variables, and operations like addition, subtraction, and multiplication. So a couple examples of what an algebraic expression would look like would be something like 3x plus 2. Notice we have numbers like 2, variables like the x, and addition signs. Possibly something like x over 4. That would also be an algebraic expression. Now, if we throw equal signs in here, such as 3x plus 2 equals 8, then it goes from being an expression to an equation. So expressions don't have equal signs, and equations do. So in this lesson, we won't be dealing with anything where you might see an equal sign, because this would be considered an equation. So let's begin with our first example, simplifying the expression. There are a couple ways that we can simplify an expression. And the first way that we're going to simplify an expression is by combining like terms. So combining like terms, so in a problem such as 3x minus 7 plus 5x, we have three terms. The terms are the part of an addition problem. So our terms are 3x, negative 7x. Notice I say negative 7 because of that negative sign right there, and 5x. So we look at the terms, the parts, and we see which ones have the same variable. So in this problem, 3x and 5x have identical variable parts. So what we do is we combine these two. So since we have a positive 3x and a positive 5x, we can put them together and we get 8x. So now the question is, what do we do with the leftover parts? In this case, the negative 7. And again, notice I'm saying negative 7 because there's a subtraction sign that comes before it. Well, since it doesn't have a variable, we really don't have anything to do with it. So we just drop it down and put it at the end of the problem. This would be our final answer because these are not like terms and there's nothing we can do with them. Okay, let's do one more problem where we have to combine like terms. I'm going to make this one a little bit more challenging, and we might have to do a few more things in it. So let's go ahead and write this down. Let's go x minus 4x minus 6 minus x. So something that you might notice right off the bat is that we have two x's that don't have a number that comes before them. That number is called a coefficient. A coefficient is a number that comes right before the variable. So the x at the beginning of the problem and the x at the end of the problem, they don't have coefficients. So what we can do is we can give them coefficients. Since they don't have a number, we can put a 1 right in front of them, and now they have coefficients, and it will make the problem a little bit easier to deal with. So now that everything has coefficients, what we can do is we can go through and we can look at the problem, we can look at the terms, and we can determine which one are alike. Remember, we look at the variables, and if they have the same variable, they are considered to be like terms. So our like terms in this problem are the 1x, the negative 4x, And again, I mentioned it in the previous slide, but we have to focus on that negative. That makes it negative 4. And finally, we have this negative 1x. So we're going to combine these terms. So we have positive 1x minus 4x and minus 1x. And 1 minus 4 minus 1 would give us negative 4x. That is something that many of you can do in your head. Others might want to use a calculator. But that is what we get when we combine our like terms. Now, as we said before, sometimes we'll have terms that don't have variables or not the same variables. In this problem, that would be this negative 6. And like I said before, we'll just drop it down right here to go minus 6. And this, ladies and gentlemen, would be our final answer because they are not like terms. So just to recap, a couple things in this slide to remember as we move forward. Add coefficients. If you need to add a coefficient, you can add ones. And finally, don't forget that if a minus sign comes before a term, we consider that term to be negative. And that is our final answer. Now that we've done 2 examples, you guys and gals are ready to go to your homework and do the first 6 problems. So I want you to pause this slide, go ahead and go to My Math Lab, and do problems number 1 through number 6. If you get confused, come back to this slide, and once you're done with the first 6 problems, come back and I will show you how to do the next set. Okay, welcome back. I'm assuming everybody has their first 6 problems done. We're going to go ahead and move on with our second example. We're going to continue to simplify expressions, but this time we're going to do it in a slightly different manner. Instead of adding like terms, we are going to use the distributive property. Now the distributive property is definitely a review. You guys did this in middle school, and we actually touched on it a little bit in the last chapter when we were talking about properties. So when I hear the word distribute, I think of passing something out, and that's kind of what we do when we use the distributive property. So let's begin with this example. Let's say I give you 7 times the quantity A plus 2. Real quick, you'll hear the phrase times the quantity pretty often, and that essentially means you're going to have a set of parentheses. So, again, we're using the distributive property. The word distribute should bring to your mind to pass out or to hand out, and that's exactly what we're going to do. We are going to take this 7 right here, and we're going to pass it out. Whoops. We're going to pass it out to both the A and the 2. Now, you might remember from the last slide, some of you might be saying, hold on, this A does not have a coefficient. Well, you're exactly right. And like I said last slide, if you'd like to add 1 in there, you are more than welcome to. We can put a 1 right there. So, anytime we distribute, we are going to multiply, and you can write that down because that's very important. We're going to multiply. So we're going to multiply this 7 by each of the terms. So 7 times 1 is 7. Do not forget the A. It is part of that first term. And then we're going to go 7 times 2, which is 14. And we can drop down this addition symbol, and there we go. So the question is, are we done, or do we have to continue? Well, if you remember for the first 2 examples, 7a and 14 would not be considered like terms because one has an A and the other one doesn't. So this is our final answer. Okay, before we move on, I want to address two places where students typically make errors. Now, the first place is right here. They will forget to drop this A down. It's a very important part of the problem. So remember, if there's a variable with it, it can't just disappear. The second spot is right here, and this might be the biggest spot that I see students making mistakes. They will distribute this 7 to the 1A, but they will forget to distribute this 7 to the 2. Remember, the word distribute means to pass out, and if you give it to one of the terms, you've got to give it to both. So do not forget to distribute the 7 to both the 1A and the 2. Okay, now that you've watched this slide, you should be ready to do problems 7 and 8 on your homework. So just pause this real quick, go do those two problems, and come back and see me. Okay, I'd like to do another quick example of the distributive property. This one's going to be a little bit unique and a little bit different than the previous ones that we've just done. So here's the example I'd like to share with you. Negative, parentheses, 2y minus 3x plus 7. So some of you might be saying to yourself, well, there's nothing to distribute and there are no like terms, so what is there to be done? Well, there actually is something to distribute, and we can distribute this negative. Now, something to make it a little bit easier, like we did with the variables earlier that did not have a coefficient, this negative doesn't have a number, so we can add in the number 1, and now we have a number to distribute. We can distribute the negative 1. And again, remember, the word distribute should kind of bring about the idea of handing out, passing out. So we're going to now hand out, distribute this negative 1 to all 3 terms. Again, don't forget that this 1 has to be distributed to 1, 2, 3 terms. And we can't forget to hand it out to all of them. So here we go. Negative 1 times positive 2y would be negative 2y. 1 down, 2 to go. Negative 1 times negative 3. Remember, that's negative 3 because of the negative sign or the subtraction sign that precedes it. Negative 1 times negative 3 would become positive 3x. And last but not least, negative 1 times positive 7 would be negative 7. So we're going to write negative 7 this way. We're going to make it minus 7. And that's the best way to write it. So there we go. We've distributed. Now we have to ask ourselves a question that we learned earlier today. Are any of these terms like terms? Well, the 2, or the negative 2, has a y, the 3 has an x, and the negative 7 doesn't have any variable. So we can say that none of these are like terms, so we can say this is our final answer. Negative 2y plus 3x minus 7. And what made this problem different, to recap, is that this negative out front here did not have a number, so we simply added a 1 with it, and then we distributed negative 1 to all of these terms. And finally, one last distribution problem. So, in some problems, you might have to distribute more than once. So let me give you a problem where you would have to distribute more than one time. So let's write this down. We've got 3 times the quantity, that means parentheses, x plus 4, close those parentheses, minus a new set of parentheses, 2x minus 7. We've got 2 sets of parentheses, and when you see a set of parentheses in math, you've got to assume that there might be some distributing going on. So, but before we get started, and before we start distributing and passing out these numbers by multiplication, let's look through this problem and see if there's anything we can do to make it easier on ourselves. So, let's look at the first set of parentheses. Can anybody notice anything in here that we could possibly do to make this problem easier? Think back to one of the previous slides. If you said, let's add a coefficient of 1 to that x, then you'd be exactly right. A nice job. So, why don't we go ahead and take care of this first set of parentheses since it looks like it's ready to go. So let's distribute. Again, distributing means multiplication. We will go 3 times 1x gives us 3x. And don't forget the second term. 3 times 4 is 12. So there we go. We can take just a short little pause and let's look at what we did. Okay, so the next thing. We've got a second set of parentheses. Let's take a quick glance at it and see if there's anything we can do to make this easier. So we're looking right here from this negative sign or this subtraction sign all the way back here. So think, what can we do to make this problem easier? If you said, hey, we need a number here to distribute, you'd be exactly right. So we're going to put a 1 there. And now we're going to distribute -1 to the 2 and the -7. -1 times +2 is -2x. And -1 times -7 is +7. There we go. Now, up to this point, when we got finished distributing, we were done. We circled our answer. We moved on. But you have to always be watching to see if there are any like terms. So we've got 3 terms. We've got 3x, +12, -2x, and +7. We've got 4 terms, and some of them are definitely going to be alike. So, we've got this 3x right here, and we've got a -2x right there. They both have x's, they're like terms, we can combine them. +3, -2, +1, x. There we go. So, we've got 2 more numbers left. Do we drop them down? Can we combine them? Well, they're like terms. We've got +12, and we've got +7. Well, they don't have variables. They're alike. +12 plus +7 is +19. And this would be our final answer. Now, one quick thing here. We want to simplify these. That's the title of the lesson. So simplify means to make small. So you have to ask yourself, is there anything we can do to make our answer a little bit smaller? And the answer is yes. We can erase this one. And this, x plus 19, is our best answer. Okay, fantastic job. You guys have done really, really well thus far. Okay, you're ready to now go to your homework and finish this up. So the problems that you can do now using the distributive property are problems 7 through 10. Might want to write that down real quick, 7 through 10. and you'll also be able to do problems 13 through 14. Now, one quick cautionary thing. Be careful with problem number 14. Problem number 14 has some fractions that you're going to have to distribute, and when you come to it, don't freak out. When it comes to distributing fractions, it's no different than distributing regular numbers. You can use your calculator. You'll just take the fraction and you'll distribute it to everything on the inside of the parentheses, and you'll be just fine. So this concludes this set of video notes. You should be able to do the majority of your homework. If you have any questions, come back, review these slides, and have fun finishing up your assignment.